The design of rotor, we have to follow some rules or suitable combinations for stator and rotor slot design. So these are the four rules to be followed for design of squirrel cage machines. Okay. So you have to remember these rules. So first rule is rotor slots should not be equal to the stator slots. That is, SR should not be equal to SS. So we are using notation SR for rotor slots and SS for stator slot. So rotor slot should not be equal to stator slot, that is one should be greater than 15 to 30% than the other. So this is the criteria to be followed, or this is the rule to be followed, that SR should not be equal to SS. So remember, now what will happen if you select SR equal to SS? Now if you select both the stator slot equal to rotor slot, then the phenomena of cogging will occur. Cogging means what? Cogging means refusal to start. Your motor will refuse to start. As you all know, three-phase induction motor, they are self-starting motors. Why they are self-starting? Because their stator slots and rotor slots, they are not equal. Then and then only your motor will self-start. So if you select both the slots are slot equal, then your motor, you will observe the phenomena of cogging in case of motor, which is nothing but refusal to start. That's why always we have to select SR uh, not equal to SS. Now second rule that need to be followed for stator and rotor slot is difference between stator slot and rotor slot, that is SS minus SR, should not be equal to P or 2P or 5P. Now here this P is nothing but your number of poles for your induction motor, which is very easy to calculate. So the difference between stator slot and rotor slot should not be equal to P, 2P or 5P. Suppose you are having number of poles equal to 2, then the difference between SS minus SR should not be equal to 2 or 4 or 10. So this is the most important criteria. Now why? Because the forward rotating harmonics are produced. Because of this, if you select SS minus SR equal to P or 2P or 5P, the forward rotating harmonics will produce, and which leads to crawling of the machine. Now crawling is another phenomena observed in case of induction motor. Now what is meant by crawling? Crawling means your motor will rotate at some sub-synchronous speed. Now suppose your motor is having synchronous speed of 1500 rpm. Now in crawling means your motor will rotate at some sub-synchronous speed. Sub-synchronous means what? Suppose you are dividing 1500 by 3. This is nothing but your sub-synchronous speed, which is 500 rpm. So your motor will rotate at speed less than synchronous speed. Now suppose here in this case it is 500 rpm. So this phenomenon is called as crawling. That is, your motor will rotate at sub-synchronous speed. So to avoid the phenomenon of crawling, you have to select the difference between SS and SR less than, or should not be equal to P or 2P or 5P. Now the third rule to be followed: to avoid magnetic locking, the difference between SS and SR should not be equal to 3P. Now again, this is the third important rule. To avoid magnetic locking means at the time of start, if your motor is magnetically locked, then your motor go into the cogging, that is refusal to start. So again you have to select the number of slots such that it should not be equal to 3P, that is 3 times number of poles. After that, the last rule: to avoid noise and vibration, the difference between SS and SR should not be equal to 1, 2, P plus or minus 1 and P plus minus 2. So here, to avoid noise and vibration, the difference between SS and SR should not be equal to 1, 2, P plus or minus 1 and P plus or minus 2. So you have to remember all these rules. So in short, your stator or SS minus SR should not be equal to 0, should not be equal to P, 2P, 5P, 3P, after that 1, 2, P plus minus 1 and P plus minus 2. So remember this rule before going for design of rotor as well as stator.